Good morning, ladies and gentlemen. So here we are at Chapter 2. My goodness, we only have, 16 more chapters to go. We are blazing through this material at light speed. So, gosh, we're only a few chapters away from being done. And, heck, I can see summer 2014 from here. So let's go ahead and get started. Chemical context of life. This Chapter 2 is basically a quick overview of chemistry and how it relates to biology. Of course, we're not going to spend a lot of time specifically on chemistry, but if you'll think back and recall in Chapter 1, we talked about that reductionism approach to studying biology, where we break things down into smaller and smaller pieces. And of course, if we do that to a certain level, we're going to be studying chemistry instead of biology. Once you start to get down below the level of cell parts and into molecules and atoms, of course, then you're into chemistry. So just a quick overview of chemistry, because biology is a wide topic, a multidisciplinary science, and of course living organisms have to follow the same basic laws of nature that relate to physics and chemistry as non-living things do. So we're going to take just a quick look at chemistry, and then we'll be zooming out and on to Chapter 3 and beyond. So the book gives a really cool example of how chemistry applies to biology, and it talks about what they call these devil's gardens. They're actually a particular species of plant or tree. I'm not going to say I can pronounce all of this, but it looks like Doroya. Doroya is what we'll call it. So here's a good quick picture. In these jungles where you would think you would find a wide variety of plants and vegetation, there are these clearings or openings where there's only this one particular type of plant that is basically filling this space. And a lot of the native peoples would call that the Devil's Garden. And there were stories of spirits or devils or forest creatures that somehow created these open spaces and these open gardens. And the scientific question was, how does this occur? It's certainly not random, or it certainly doesn't seem random. It certainly seems like someone is tending this garden and basically taking out all the other vegetation and plants and somehow keeping this Doroya tree as the main species, or the species that's profiting from this care. So we have some scientific experimentation that was done, and here is what we were looking at, or here's what the scientists were looking at. They were trying to determine if ants there in the forest had anything to do with these devil's gardens. So what they did is they set up a quick experiment where they had two different types of small trees. They had the Doroya tree, which is the favored species, and then they have what they have called cedrela saplings. And they had to have some controls because, again, you wouldn't have a good scientific experiment without some controls. So what they did is, within an existing devil's circle or devil's garden area, they planted some of these cedrela saplings that were not there when they first found the circle. They planted some of the saplings unprotected, and then they also planted some of the saplings with an insect barrier around the trunk to keep any insects basically off of the sapling. And then, to further their controls, outside of the Devil's Garden circle, they also planted these cedrelas. Again, one set of them had the protection, the insect protection, and then one set did not. And then they left that for a certain amount of time. So here we go. We have the intended species, or the found species, the Doroya trees, and they planted the cedrelas both within and outside of the Devil's Garden. Some of them protected from insects, some of them not. Here's the data that they collected, and sure enough, you can find that where the saplings, the planted saplings, were found, the cedrela saplings, inside the Devil's Garden and unprotected, just in a matter of one day, they had a large amount of tissue damage, leaf tissue damage. All of the other controls, either inside and protected or outside of the circle or outside and protected, you'll notice had very little damage. So in a day, there was very little damage on the leaves found in any of these control groups, but here the non-wanted species within the Devil's Garden, the ants went to town and basically did quite a bit of damage to the leaves of that species. So in the end, it turns out not to be devils or spirits that was gardening the forest here, or the jungle. It was the ants. The ants, for whatever reason, perhaps the Doroya tree provides them some sort of food or shelter. That was the favored species for the ants. So they were basically clearing the forest areas of other species using formic acid, which is the acid in the ant's sting. So they were basically stinging the leaves and injecting formic acid, which would do damage to the leaves the same way it does damage to your skin. And over time, they were killing off any other species except for the Doroya trees or plants that they wanted inside their little circle. So they were building themselves a little ecosystem or a little city that benefited them. So in your textbook there, a great example of how biology is affected by chemistry, or how chemistry is basically an integral part of biology. You can't really study biology well without at least stumbling onto and studying a little bit of chemistry. Our first concept, Concept 2.1, is just an overview of basic chemistry that you're probably already familiar with, but it never hurts to go over it again. And it says that matter consists of chemical elements in pure form and in various combinations called compounds. All living creatures are composed of matter. Matter is anything that takes up space and has mass. Basically, if you find something in the universe that takes up space or has mass, it is made up of matter. There are other things within our universe, such as energy, but here we're talking about the actual physical material that makes up living creatures. So matter is made up of either elements. An element is a pure substance that can't be broken down any further by chemical reactions. So you're talking about pure atoms of a particular one element. Or you have combinations. Of course, living creatures are fairly complex, so for the most part they're made up of compounds. And a compound is a substance that is a mixture of two or more elements in a fixed ratio. For example, water is a compound. Water is made up of two atoms of hydrogen, one atom of oxygen in that fixed ratio. You could have a single molecule or a billion molecules of water, but each one of those molecules will be in that fixed H2O ratio. A good example is salt, and this is a good example of how the compound, the sodium chloride, which is the salt you put on your french fries, has completely different properties than the parent element that created it. Sodium is a kind of a silvery, soft metal that can be very reactive, can actually be explosive when it contacts water or moisture in the air. It's oftentimes stored within oil in glass containers to keep it from contacting the air. Notice this person is wearing gloves primarily because the moisture on their skin would actually probably react with the sodium as well. And then chlorine, here in the sealed container, chlorine is a greenish colored gas, can be very deadly. If you were to inhale chlorine, it would do some immediate damage to your nose, mucous membranes, and lungs, and you would not want to inhale that directly. But in the proper combination of one atom of sodium, one atom of chlorine, they form a chemical bond. It creates sodium chloride, which is salt, which your body has to have, and you put it on your french fries every day. So the properties of salt are far different than the properties of the individual atoms or the individual elements that make up that salt. If we talk specifically about the elements that make up living creatures, only about 20 or 25% of the 92 naturally occurring elements on the periodic table are essential for life. So the vast majority of those elements you see on the periodic table are not really a part of your body or not an essential part of your diet or anything like that. As a matter of fact, there's 4 elements, carbon, hydrogen, oxygen, and nitrogen, that make up the vast majority of living matter, whether that's a tree or an earthworm or a human being. And then that other 4% consists of primarily calcium, phosphorus, potassium, and sulfur. So altogether you have about 8 elements that make up the vast majority of all living creatures. And then the very tiny percentage left is called trace elements, and those are what's required in very, very, very tiny amounts. So here we have kind of a breakdown, and you can see that the oxygen, carbon, hydrogen, and nitrogen by far make up the largest percentage, and that would include the water in your body, the H2O. So there's a lot of the hydrogen and oxygen because it's a good 3/4 of your body to begin with. And then almost all of the remaining fits into a fairly small list, and then you can see the trace elements listed at the very bottom. Of course, some of the elements in the periodic table are not only not needed for life, they're actually harmful to life. So, for example, the element of arsenic, which you are probably familiar with, at least through books or movies or TV. that is a toxic element. A very small amount can cause the death of a living creature. So, unbelievably, there are some creatures, though, that have become adapted to certain ones of these toxic elements. So, for example, in the book, they talk about some plant communities that are adapted to something called serpentine or serpentine soil, and they show some pictures here. So this is a serpentine plant community. In the particular picture that's kind of at the upper right here, this is a type of lily called a Tiburon mariposa lily, and it apparently can live in this soil, which contains a number of elements that are generally toxic to most plants. So if you were to transplant an oak tree or transplant some daffodils to this area, they probably wouldn't last very long. They'd probably die. But there are some plants that have become well adapted and tolerant of these particular elements. They probably don't thrive on them, and they are probably not an essential part of the diet or the intake of these plants and animals, but they have become adapted to tolerate what would normally be a toxic element. So we're going to end right here for concept 2.1, and we're going to end with a quick little video. If you've ever heard of the group They Might Be Giants, kind of a cool group. They have a little CD called Here Comes Science, and of course it's primarily geared toward elementary or middle school students, but I'll tell you what, they've got some catchy tunes, and we'll take a quick look at one of them here. So I'm not going to run the video here, but if you go to the Schoology site for your course, you can probably find it. I probably linked to it or perhaps put it in under the materials. Go check it out. Enjoy that. Take a break. Come back and we'll pick up with concept 2.2.